Hello, in this video we're going to learn a very important rule for differentiation, which is called the chain rule. So before we do that, let's just see an example. If I give you y equals e to the x, and the question is find dy by dx. So all you have to do is look at the function and match it with the formula and tell me the answer. So this lists that exponential, so the answer is e to the x. So the answer here is just e to the x, right? Because it remains the same. But what if I give you y equals e to the x square now? And let's put this in a bracket. And the question is find dy by dx. Now you look at the function and then you look at the list of formulas. It does not match with any one of them because the power here is x and the power here is x squared, but still the e matches, so you can still use the exponential function. So what is the chain rule? Is that you differentiate the whole thing first times the differentiation of the bracket. Differentiation of the whole thing remains as it is because it's e to the x square, because e remains as it is, exponential remains as it is, times the differentiation of the bracket. Now the bracket is x square, which is of the form x to the n, so it should become nx n minus 1. So this should be times 2x. So final answer 2x times e to the x squared. And this is using the chain rule, which says if you have f bracket ux, then it should become f prime, keep the bracket as it is, times u prime of x. So if you compare this example to the formula that I just gave you, your bracket is ux. So first you differentiate the whole thing, which is that, times the differentiation of the bracket, which is u to the x. Okay, maybe we can do one more. Let's not delete the rule, so let's delete this. Okay, let me give you one more. Say I give you y equals, say, ln of x cubed plus 4. Something like this, and the question is to find dy by dx. So remember, you differentiate the whole thing first, keeping the bracket as it is, and times the differentiation of whatever is inside the bracket. So first differentiate the whole thing, which is ln function. So you look at the ln function, which should become 1 over x. Whatever is in the bracket needs to come to the bottom. So the differentiation of the whole thing is 1 over x cubed plus 4. We differentiate the whole thing, whatever is in the bracket comes to the bottom, times the differentiation of the inside. X cubed is of the form x to the n. That should become nx n minus 1 from the formula list, so it should become 3x squared plus. Now remember, the differentiation of a constant is 0. So, and then you combine the two together, final answer 3x squared divided by x cubed plus 4. So any such problem, differentiate the whole thing first times the differentiation of the inside. Chain rule is very important. So you have to understand this by doing practices. Let's do one more. If I give you something like this, y equals the square root of x to the 4 is 9. And the question is find dy by dx. Okay, the first thing is, before you apply the chain rule, you need to get rid of the root somehow and make it into a power. So whenever you see a root, the power is 1 over 2. So just remember, if you see the root, the power is 1 over 2. Now this is of the form x to the n, where n is half. So you differentiate the whole thing first using x to the n times the differentiation of the inside. So this should become n, which is half. Keep the bracket as it is, because the chain rule tells you keeps the bracket as it is. N minus 1, half minus 1 is minus half. This is the differentiation of the whole thing times the differentiation of the inside. This is again of the form x to the n, so it should become 4x cubed, and the constant should become 0. So remember, the differentiation of a constant is 0. And then you simplify, you should get 4x cubed over 2 root x to the 4 plus 9. If the power is negative, you bring it back to the bottom, and half means it's a root. You see, if you can simplify more, 2 can cancel this, making it 2. So you should get 2x cubed over root x4 plus 9. And this is your answer. So remember, any such problem where your formula does not match, your function does not match with the formulas, but they look similar, you will have to use the chain rule. Very important chain rule. Any questions, you can type in below.